Hey folks, welcome to the next session of CAT 2025 Slot 1 PYQ questions. And in this session, we're going to solve questions on algebra. 6 questions in Slot 1. So let's solve one question after the other and understand how well we are prepared for this now. So to begin with, start with this question that says, if a minus 6b plus 6c is equal to 4 and 6a plus 3b minus 3c equal to 50, a, b and c are real numbers, the value of 2a plus 3b minus 3c. I first looked at this and then thought I have 3 variables to solve for, and then there are only two equations given. I have to find 2a plus 3b minus 3c, and then I had a feeling both equations should have something in common that will help for us, and then realized that this is 6b 6c, this is 3b 3c, this is 3b 3c. So all of them are in that pattern. So I can nicely think about retaining B and C and work something around it. What do I mean by that? I can write this equation as A minus 6 into B minus C is equal to 4. Taking out minus 6 common, I'll have A minus 6 into B minus C equal to 4. Here, I can write this equation as I have 6A plus 3b minus 3c. I want to multiply this equation by 2. So this will become 12a plus 6 into b minus c is equal to 100. This way we can b minus c and find the value of a. Sorry. So let's subtract. We can straight away add this 13a. This gets cancelled, is equal to 104, or a is equal to 8. We have a is equal to 8. Put a equal to 8 in this equation now. So you'll have 48 plus 3b minus 3c is equal to 50, or 3b minus 3c is equal to 2. That's what we exactly need, 3b minus 3c. So we'll keep it as it is. Add 2a to this. So 2 times of 8 plus 3b minus 3c is equal to 16 plus 2. That's 18. Answer option A. Nice question. It took me off for a second, and then I realized there should be some connection to work around it, which it did. The number of distinct integers n for which log of n square minus 7n plus 11, the base 1 by 4 is greater than 0. Looking at an inequality here with log, so log of something is greater than 0. It has to be greater than 0. So we can work around that. Now we know for a fact that anything that's given in the form log n to the base a equal to x can be rewritten as a power x is equal to n. If I plug it in over here, I'll get 1 by 4, the whole power 0. Here we have the base, here we have the power over here. 1 by 4, the whole power 0 is greater than n square minus 7n plus 11. Anything power 0 is 1. So I can write this as n square minus 7n plus 11 is less than 1, or n square minus 7n plus 10 less than 0. So minus 7n, minus 7 plus 10, minus 5 and minus 2. So n minus 2 and then n minus 5 less than 0. So the critical points will be 2 and 5. So anything lesser than 2 you put here. So you put anything less than 2, this is greater than 0. Put 1, you'll have 1 minus 2 minus 1, 1 minus 4 becomes positive. In this range it is positive. Put anything greater than 5, it is still positive. Only in this range it is negative. So that's how we look at it. N minus 2 and n minus 5 less than 0. We are looking at integer values. So n can take values 3 and 4 only. Between 2 to 5 anything works. So we would have said n belongs to the range of 2, 5. But 2 and 5 excluded. So n can be 3, n can be 4. But we also understand that log of a negative value does not exist. Log of 0 does not exist. This value should be greater than 0. N square minus 7n plus 11 should be greater than 0. Why? Log of a negative value is not defined. Log for any negative value is not defined. Log of 0 is not defined. So this clearly has to be positive. So on that account, n square minus 7n plus 11 is greater than 0. I'm not going to solve for it. I'm going to plug in the values given over here, 3, 4 over here, and then work around what it is. If I put n equal to 3 here, I can write this as n into n minus 7 plus 11 should be greater than 0. Put n equal to 3, we'll have 3 into 3 minus 7 is minus 4 plus 11 is equal to minus 1, not greater than 0. So n equal to 3 doesn't work. N equal to 4, 4 into 4 minus 7 plus 11 should be greater than 0 for me. But I multiply this, I will get 4 into minus 3 plus 11 is equal to minus 1. N equal to 4 also doesn't work. For this condition, I got n 2 values. But then I substituted for the other condition. Remember, you have to apply both conditions and then see which one works. The two integers that I obtained here, when I plug it for the other condition, did not work. So how many distinct integer values do we have? 0. And that's our answer. You need to be very particular about it. The moment you get this, our eyes will lit up and then you look for 2. Have 2, you would have chosen it. But then that's not the case. You need to be very particular about every condition that needs to be satisfied. Right? The next one here, the number of non-negative integer values of k for which the quadratic equation x square minus 5x plus k equals to 0 has only integer roots. You need to look for only integer roots here. So the equation given here is x square minus 5x plus k equals to 0. So the two roots has only integer roots. Alpha plus beta is equal to 5. Alpha beta is equal to k. The one thing that we know is k is greater than 0. So the product of two numbers is positive. So either both of them are positive or both of them are negative. That's the only case that we have. But then I notice alpha plus beta is 5. If both the roots are negative, product will be positive, but the sum would become negative. That can't happen. So in that case, I can clearly say alpha comma beta, both of them are positive only. Because if you take positive negative, product will become negative. But by condition, I know k is a non-negative integer. So positive, negative, negative, positive is by default ruled out. So if k has to be positive, both roots are negative or both roots are positive. This is the only two cases that we have. But then I also notice that sum of the roots is positive. Both of them have to be positive. That's the only case that we have. On that account, I can think about this as alpha plus beta is 5. Alpha, beta are positive. They are integers. So I am looking at 0, 5, 1, 4, 2, 3. So in that case, k can take values of 0, 4, 6, 3 values. And that's our answer. Or you can look for the determinant part and then work around it. You know our determinant delta is greater than or equal to 0. Why? Because they have non-negative integer values and my root of b square minus 4ac is an integer. Right? It's positive. It's a positive integer. Then only you will have integer roots here. And then you can look for it. Put minus 5 the whole square minus 4 into 1 into k. So the root of 25 minus 4k. For this to come out as an integer, what all values can I put? I can put k equal to 0. Put k equal to 0, root 25 will come out. works. Can I put k equal to 1? Won't work. The maximum value of k that you can put is 6. 4 into 6 is 24. So root 25 minus 24 will come out to be positive. Will come out to be an integer. So I can put k equal to 6. K equal to 0. This will become 5. So it works. If you put k equal to 1, 25 minus 4 won't work. K equal to 1 won't work. K equal to 2, 25 minus 8, no. K equal to 3, you put, if I put k over here as 3, 4 into 3 is 12, doesn't work. Put k equal to 4, 4 into 4 is 16, 25 minus 16 is 9. So k equal to 4 works, k equal to 6 will work. So you can also think about it this way, or this is a simple way to look around it and get our answer. A value of c for which the minimum value of f of x is equal to x square minus 4cx plus 8c is greater than the maximum value of g of x is equal to minus x square plus 3cx minus 2c is. So you can do completion of squares, or you can remember the maximum value of x. Where does the maximum value of x happens and where does it happen? You can use those formulas just in case we know what we have to find for any parabola, an upward facing parabola where a is greater than 0. The equation is ax square plus bx plus c equals to 0. If a is greater than 0, you are looking for minimum. If a is less than 0, you are looking for an inverted parabola. In that case, this is maximum. We remember that. And the maximum value happens, maximum or minimum value happens at 4ac minus b square by 4. You can use the formula to find where the maximum value happens and then look around it. Or you can do it by b by 2a and then get it done. This you can use, but I'm going to do it with completion of squares over here. So f of x is equal to x square minus 4cx. So this will be 2c then. 2c will become 4c square minus 4c square plus 8c. This I can write it as, this entire part will become x minus 2c the whole square. X minus 2c the whole square plus 8c minus 4c square. This will be f of x. So the maximum value for this, the minimum value will happen at 2c. X is equal to 2c, you put here 8c minus 4c square will be the minimum value. So minimum value of this expression would become 8c minus 4c square. Similarly, for g of x, it will be minus of x square plus 3cx. 3c by 2 is 1.5. 1.5 is 3 by 2. So that will become plus 9c square by 4 minus 9c square by 4 minus 2c. Right? We'll have this. Oh, sorry. Minus is taken out here. So this will become minus 3cx plus 2c. Minus 3cx plus 2c because minus is taken out. So once again, this part we can write it as x minus 3 by 2c, g of x is equal to minus of x minus 3 by 2c, 3c by 2 the whole square minus 9c square by 4 plus 2c, or bring this negative inside, and the maximum value will happen at 3c by 2. So this will become 0. So the maximum value here will become 9c square minus 8c by 4. So this will be the maximum value. By data, the minimum value of this expression is greater than the maximum value of this expression. So this is greater than this. Let's write it down. I'm running out of space here. Then we'll write it 8c minus 4c square is greater than 9c square minus 8c by 4. Take this over here. You will get 32c minus 16c square greater than 9c square minus 8c. Bring everything to one side. You will have 25c square. This comes over here. 25c square, this goes over there, becomes minus 40c less than 0. So divide this by 5, take c common out. So divide this by 5 and taking c common out, you'll have c into 5c minus 8 less than 0. So once again, our critical points will be c equal to 0 and c equal to 8 by 5. Our critical points 0, 8 by 5 is 1.6. So less than 0, I understand that anything here is positive, anything here is positive, here only it is negative. So from our critical points, put anything less than 0, this will become positive. Anything greater than 1.6, it will become positive. Put 0 or 1.6, it will be 0. So the only values over here will be values between 0 and 1.6, excluding that. I'm looking for a value that satisfies that condition. 2 does not, minus 2 does not, minus 0.5 also does not do it. 0.5 does it. And that's our answer. Nice question. If you are struggling to do it this way, straight away plug this value. The moment you plug in this formula, you will straight away get these two equations. And then you can solve for the inequality and you are through. According to this question, put ax square plus bx plus c for this equation. You will exactly get 8c square minus 4c square. So you'll get that. But I prefer doing it with the conventional way, and that's how you get it done. The number of distinct pairs of integers x comma y satisfying the inequalities x greater than y greater than or equal to 3 and x plus y lesser than or less than 14. So y takes a minimum of 3, x takes greater than 3, and we are looking at all integers here. I'll have to brute force this method now to get this done. So every time I take a value for y, and x. So let's look at y takes a minimum of 3. X can start with 4, 5, go on till a point x plus 5 is less than 14. So y is 3. If I put x is equal to 11, x plus 5 will become 14. So x cannot be 11. X can take a maximum of 10. So 4, 5, 6, 7, 8, 9, 10. There are going to be 7 values here. If I put y equal to 4, x starts with 5, but cannot end with 9 because cannot end with 10. 4 plus 10 would become 14. So the largest value that x can take now is 9. So 5, 6, 7, 8, 9. There are 5 values. Put y equal to 5. X starts with 6. Cannot take 9. 5 plus 9 would become 14. Has to be less than 14 again. So the maximum that I can take is 8, 6, 7, and 8. The next will be 6 here. If I take y is equal to 6, x can take 7. If x takes 8, 6 plus 8 would become 14 again. Not possible. So 3 possibilities here and then 1. So 3, 4, 3, 5, 4, 3, 5, 3, 6, 3. All possible integer pairs will satisfy here. So 7 pairs here, 5 pairs here, 3 pairs here, and 1 pair here. All together, we can get 16 different pairs. And that will be our answer. Nice, simple question. Once again, you might have to brute force this, sit and write it out, and then get your answer. So let 3 lesser than or equal to x lesser than or equal to 6 and the greatest integer function of x square is equal to the square root of the greatest integer function of x, where this is the greatest integer not exceeding x. What is the greatest integer function? Simple. The greatest integer function of 5 is 5. The greatest integer function of 5.1 is 5. 5.99999 is still 5 only. Doesn't matter. 5 point anything until it doesn't touch 6. Greatest integer function will always be 5. Nice idea. So they are asking for a possible subset. Now you can take every possible subset given over here and see whether it, when you substitute it over here, it works, or you can extract the entire range, so the possible range of values that it will work. So look at this, square root of the greatest integer function. Now notice this, from 3 to 3.9999999 for x, anything between 3 to 3.999 for anything. Greatest integer function of this will be 3 only. Square that, you will get 9. So 4 to 4.999, this will give you 16, because the greatest integer function for this range will be 4 only. So 4 square will be 16. Similarly, the next possibility will be 25, 5 to 5.99999 and so on. And then lastly, you will have 6, 36. Because beyond 6, none of the values are there. So 36 is possible. For 6, greatest integer function of 6 will be 6. Square that, you'll get 36. Now this one we have carved out. Now the greatest integer function of x square needs to be 9. Looking at this, this is what we are looking for. What does it mean? For some value of x that you put here, and then you square it, and then you take greatest integer function that goes to 9. Now nice. Now think about it this way. Root of 9, if I put x to be root 9, x is equal to root 9. So this will become greatest integer function of root 9 square. That will be 9. Correct? Put 9.1. So the root and the square gets cancelled. Greatest integer function of 9.1 will be 9. Put 9.2, you will get 9. Put 9.3, you will get 9. 9.999999. If you put x is equal to 9.999 dot dot dot. So what do you get? Greatest integer function of the square root of 9.99. The square, this will still be 9 only. That won't change. But the moment you put x equal to 10, the moment 10 comes here, this and this will get cancelled. The root and the x square will get cancelled. And you'll get straight away 10. That means any value less than 10 for x, any value less than 10 I put here holds good. It cannot hold 10. Anything less than 10 it will work. In that case, I can say x belongs to, I can include 3, but I cannot include 10. Correct? Starting from 3 here, for this value, start from 3. Any value less than 10, take that root and cancel it out, you'll get. This is when the integer function of x square is 9. Similarly, if you look for 16 here, so the greatest integer function of x square is 16. X will belong to 4 included, but 16 point anything will work, 17 will not work. So you can similarly carve out this entire part. Union 4 included, root 17 not included. Union 5 included, root 26 is not included. Similar, square of this number, add 1 to it, put a root on top. That's the pattern you are looking at. Union 6. So all of these values will work, but then not everything is given here. Been given subsets of this range. So in that case, I'm looking at 4 comma root 17. Nice. 3 comma root 10. 3 comma root 10. We're looking at a lot of values that we have carved out. But range, what are the limits? Look here. 3 comma root 10 is given here. But it says both of them are included. But we clearly saw you cannot take root 10. This is wrong. This is also wrong. Root 26 cannot be included. C is ruled out. Looking at B, it says root 10 is included. Root 17 is included. No, this is incorrect. This is also incorrect. B is eliminated. Looking at this, nice. 5 included, root 27 not included. We just saw root 26 itself is not included in the range. It says root 27 is not included, which means it is telling us root 26 is possible. No, this one goes off, leaving us with only option D, which has to be our option. Then let's verify. It says 3 not included, root 10 not included, but we just saw 3 is included. It's okay. Now it's a subset of it. Now you can include 3 is the actual fact. I'm saying it's a subset, but this one works. 5 to root 26, root 26 not included. Yes. And then 6 is included. Yes. This has to be our answer. Nice question. If you know what greatest integer functions are, then a challenging one indeed.